Hey everybody, I'm Hilary O'Connor from Google Cloud. Thank you so much for joining us this afternoon. You can see it's actually not so glorious coming along and joining us. Tell us a little bit more about yourself.
Yeah, quick little overview. My name is Brian Grantier. I've been doing web development for a really, really long time. And I was there with the cloud when it first started forming, before they were kind of raining. And I worked at Hewlett-Packard in the United States for a number of years doing web services there, and then moved on over here to New Zealand and then worked for a couple companies here.
I was going to say you're a Kiwi now, but you don't sound it. So where are you from originally?
Yeah, state of Oregon. So that's the one just north of California in the good old US of A.
Fantastic. All right, so how about you tell us a little bit about smart parking, its mission, and maybe some of its key differentiators?
Yeah, so smart parking, from the very beginning, it's still at its core, is about taking cutting edge technology and applying it to parking solutions. The audience might be most familiar with what we do when they go to a parking structure. You'll see numbers that say, well, on the first floor, there's 23 spots, but on the second floor, there's 178.
So helpful.
Yeah, people like those things. And then from there, we do a lot of other things just around the whole parking solution thing. We develop the sensors. We're using the most accurate technology we can to be able to detect the arrival and departures of vehicles. And then we give that data and we allow our customers to be able to use it. And more recently, we've been moving from just doing parking stuff into smart cities. So this is being able to normalize it and really focus on things like analytics and being able to do business decisions based on no matter what kind of information you're getting coming in.
That sounds awesome.
It's a lot of fun.
So you've talked to us about your mission and about moving from smart parking to smart cities. So can you describe a little bit more about the IT strategy at smart parking?
Yeah, so I think this is probably a pretty familiar narrative. So we're like a lot of these companies that went from just being a product company that was developing and deploying and supporting these sensors. And then we moved into a company that was about services, right? The things that go around those devices. And now, like many of you out there, I'm sure doing, we're moving into this data-driven idea. So the idea is that we want to be able to not only get in as much data as possible, but help people be able to get meaning from it. That's live, real-time updates of data so that they can make decisions in the moment, be it the customers who are, have admins that are looking at their sites, looking for things that might need maintenance, or it's a customer who's looking to try to find guidance to take them to where they can find good parking. So moving from being a company that was very much one product to being a data-driven company, an API-first kind of company. So that's kind of what our strategy has been recently.
Sounds great. So with a strategy, there also comes challenges.
Yes, and those challenges, a lot of people I'm sure will be familiar with. So two major challenges. One is maintaining the devices. So we have hundreds of devices at any given site, not just the ones that go in the ground, but the ones that pick up the radio signals and a variety of other things, cameras, gate guards, and all these other systems as well, pay machines and all that. So getting devices deployed and getting data come to us is a real challenge. And fortunately, we've been using IoT Core to do that, which has been an absolute, thank you, it's been wonderful. And then another challenge we have is just the sheer amount of data. So when you're streaming data from the devices for related to parking, there's a lot of parking events. You look at vehicles coming and going just at a single lot, you're talking about hundreds of events and a lot of data. But when you go up to city scale, you're talking about even more vast amounts of data. And that's been a real challenge for us, has been how do we, A, get these devices deployed, B, get the data in, and then C, be able to make meaningful usage of it without it being expensive and really, really hard.
Two great factors to consider, absolutely.
Yeah.
So tell me about some of the specific motivators that led you to look at GCP and Google Cloud Platform.
Yeah. So maybe a little history about me. So like I said, I've been doing this for a long time, and I originally was always an AWS guy. So Amazon Web Services, loved it, used it at all my jobs. It got me lots of promotions because I'm like, hey guys, we should use the cloud. And everyone's like, ooh. And I was able to get that rolled out there, and it worked really, really well. And when I came to smart parking, initially I'm like, well, AWS is the way to go. But we began to look at the space we were in, the streaming data, this high volume of data, and we started reading white papers, a lot of them written by Google, and consulting experts and stuff, and looking at what the trends were. And we found that Google offers a number of services and basically kind of philosophies of how you build your stuff that worked really well with what we were doing, both in a parking and a smart city thing. So we said, oh, hey, well, okay, Google's got some cool things, so let's give it a go. So me, I'm like almost all the developers I'm out there. Sure, I'm very resistant. I'm going to use Vim, and I'm going to use Linux till the day I die. Just like I love these things. So I was like, "Ooh, okay, well, I'll give Google a go." And sat down, and I was able to build a prototype of our thing on App Engine in a couple of days, literally in a couple of days. I'm like, okay, that was kind of fun. And then we started expanding it, introducing things like pub subs and cloud functions and data store, and it just kept going and going. We were able to prototype and get things deployed and tested and out there so quickly. It was almost like Google chose us, right? It was like we started going, and it was too easy. It was too easy to build things, and you were seeing things come online. We're talking about going from an idea of this new version of our platform in the smart cities, just a twinkle in the eyes and some ideas, to being here, real, and actually usable in a year, which is, I don't think could have been done if we hadn't been able to have access to Google's cool platform of toys. It was great stuff.
That's pretty powerful.
Yeah, it definitely is.
So you've talked a little bit about AWS, but I'd like to dive a little bit more into what your evaluation process was like and what other environments did you consider out there?
Yeah, so I mean, like you got to go look at all of them, right? You got to look at AWS, you got to look at Azure, you got to look at Google, you got to look at all these clouds because they all are working really hard. There's really smart people working on all of these clouds. And so what we did is we said, well, we want to look at what they've got there. And we gave it a try, we kicked the tires. But I think the thing that really comes down to it, like I said, I'm really an AWS guy. And it kind of feels like when you're using AWS, it's like entering a giant workshop, and there's tools for everything, and there's materials, limitless materials, and over the doors a sign that says build anything. And then when I went to Google, it was kind of like walking into a laboratory from the future. You got nuclear reactors, AI assistants, flux capacitors, you got
sharks with lasers,
you got everything. Yeah. And there's still a sign over the door, but this one says change the world. I felt like I was entering into almost like a playground of really cool technologies. And as we'll go through this, I'll talk about how we've hooked them all together, and we've been able to build something that not only scales really well, but is a lot of fun. So the evaluation process, just being able to try it, and the fact that Google's got great documentation, great examples, great code on GitHub, it was really easy to just get going. And then once you get going, it just keeps going and going and going and going.
Excellent.
Yeah.
I'm loving the sharks with lasers as well. Okay, so what aspects of your architecture and smart parking's business make it either particularly challenging or a perfect fit for Google Cloud Platform?
Yeah, so I mean, like I've said at the beginning, this is really an IoT problem. This is really a device situation. So what you really need to do is you need to say we need to deploy devices not for parking, but we also need to be talking about devices of any kind. The typical IoT thing. You got the fridge that's really smart, and you got the doghouse that's really smart. How do you relate it so that I know next time I go get milk, pick up dog food? That's the challenge. We've got a lot of data, but how do we use it? And so one of those challenges, and Google brings it, is the IoT Core. So IoT Core is their IoT platform, which allows us to really easily onboard devices. So we're taking devices, we're getting them set up, we're getting the security, we're deploying them in the field, and then they're talking to us. And when you talked about it, we used to do this homegrown. It was all about, okay, how do we get the certificates on the devices? How do we get gateways talking? How do we do this, that, and the other? Anyone who's familiar with IoT Core will know, IoT will understand those challenges. And IoT Core makes it really simple. So that was one of those things where we gave it a try, and one of our developers, Ken, was working on it, and he just sat down with IoT Core, and it took him about a week to get our devices up and going on it perfectly. So since then, we've just been using the thing, and we haven't had any problems. I mean, it's just been a rock star. Nothing's fallen over. We're just adding stuff to it. It's just been amazing. So that was one of those things where Google's architecture and those things worked. But the thing that probably really highlights it is the scale. So Google's products, Google's cloud is built for Google scale. They use these things. YouTube, Gmail, all those city scales. That's pretty big. But we're Google is talking Google scales. Is that what the internet scales? We're talking everything. So we knew that we went into Google, we were going to get access to tools that were going to scale with us, and we're going to be able to deal with the data, the challenges of data. That's what it is. It's data from devices. It's data from external systems. It's everything a city has and everything it wants to say. And we had to find ways to bring it together. And Google lets us do that because of the power of their tools.
So at a high level, because we're going to dive into some of these in some depth, but specifically what GCP products and services are you using? It might be quicker to tell us what you're not using.
Yeah, because we use a lot of them. Like I said, it's real easy to get into these things. So I mentioned IoT Core, which is great. You to bring in this pub sub, it's amazing. except for BigQuery. BigQuery is another one we use. And I do firmly tell people, if you've never used BigQuery, you have to give it a try. It is magic. We're talking running a query against terabytes of data, just going crazy. I'm going to run a SQL statement that joins these two tables and does all this stuff. And I'm going to go through terabyte data. I'm going to get a response in 3 seconds to where I can actually, where I can actually say, I'm going to fulfill real-time UI stuff with queries that are hitting my data set, my data lake, not just a little thing that's been, materialized overnight. I'm talking everything, because BigQuery can do it that fast. So BigQuery, data store, Bigtable, both great ways to store it. Spanner, which is like the new
computer
amazing
science miracle.
Yeah, I know. It keeps blowing my mind. And then we're also looking at, we use cloud functions, and I just love cloud functions. It's just the idea of using serverless. So like I said, we originally prototyped on App Engine, which is, that scalable, basically what most people would be used to, EC2 instances on AWS for those people out there. But we've been moving and doing more serverless stuff, cloud functions and serverless databases and things like that. And it's been tremendous. And so all the stuff that's there, machine learning and all those other things as well. We just, it's so easy to take your stuff and say, I'm just going to turn on this new service and try it with Google. Data Studio. One that never gets any love is the login system, Stackdriver. It's fantastic. Yes. I love Stackdriver. And just being able to use those things is really, really cool. And they all play together really, really nicely.
Great. Well, I'm excited to dive down a little bit more into some of these. So firstly, tell us a little bit more about how you're using IoT Core. And also, you mentioned before that you've been using it for quite a while, and it's been rock solid, et cetera. And it's been in beta for most of that time, which is pretty awesome as well.
You get in beta and you think something's going to be rocky, but no. IoT Core, like I said, it's really about that fleet of devices. It's the messages we're getting in are coming from our devices, and it's the two-way conversation. So it's not just, I want to be able to securely have devices talk to me, but I want to be able to securely talk back to devices. If I had to go build my own security layer for IoT, that would be painful. But fortunately, like all of the GCP products, it's backed behind the wall of Google security. So I don't have to really worry about security. It's there. So getting devices, getting them deployed, getting them secured, all of those things is one of the reasons that IoT Core has been so good. It was easy to get in, and like I said, you stay around because it lasts. And it's really easy to say, hey, I'm going to take all this data that's coming in, I'm going to put them onto these pub sub queues, and then I'm going to just act upon it. We use cloud functions to just start reacting. So when any message comes in, the lights start blinking and everything goes. So it's been a real, like you said, it's in beta, but it's been a rock star for us. We've really loved it.
Oh, fantastic. And is there anything else you want to share about maybe your use of PubSub? Because IoT Core obviously is very heavily intertwined with PubSub. Yeah, so PubSub, for people who aren't familiar, it's a queuing system. So you're able to get messages in, but the beauty of it is you're able to trigger off of it. So we use cloud functions. So when a message comes into PubSub, we will immediately send it to a cloud function, which is it's a great way to code, let me tell you. I really love it. If you can get a chance to build an architecture that's based on PubSub messages going into cloud functions, you're going to love it. It revitalized my love of developing web services. I've been doing it for years. And so IoT Core basically lets us put these messages in, and we've developed an event-driven architecture that's based off of this flow of data. So for people who don't know what event-driven architecture is out there, I recommend looking it up. It's a really fun way of building a system. It's the idea that everything in your system is an event, and you're reacting to those events. And it becomes very, very fluid and very organic when you're doing it on Google with PubSubs and serverless technology. Fantastic. So you've talked about data a lot.
Yes.
So what do you do with all of that data that's coming in?
And that's
cities worth of data.
Yeah, exactly. And there's that old terminology, you get the data lake, right? Just putting all the data in there, and that's where developers go to drown. It's the real thing. I've got all the data now coming in. IoT Core lets me stream in all this data, but how do I do something with it? And fortunately, that's where Google's right at. Google cares about data. They always said, their goal is to take all the data, make it universal. It's just we want to do this data democracy. That's the idea, is that data shouldn't be just for the nerdy guy who's sitting, I know the classes, the nerdy guy like me who's sitting at the computer doing this stuff. It should be something that anyone can go to. Anyone can say, hey, I want to go look at the data that is my business, and I've got a question, and I want to be able to ask it. So Google allows you to have this data democracy. Big and most importantly, a lot of it is through that BigQuery. Like I said, BigQuery is fantastic. It allows you to pull in all this data together and run these queries. And one of the things you always want to do when you talk about terabytes of data, you're like, oh, well, I want to get a sample set. I'm going to write this tiny little thing. I'm going to see it works. And then I'm going to go run it against the larger thing. And oh, wait, the larger thing changed on me. And you get in this kind of where everything's rattling. But when you're using BigQuery, it's amazing. You can just sit down and say, I'm going to write a SQL statement. I'm going to have it hit my terabytes of data. This is BigQuery. We have data.
So you've talked, at the beginning, you talked about Data Store and Bigtable and some of the other databases that Google has. So how are you using those?
Yeah, and that's one of the things that's really important. So when you're looking at modern web services, and you're not talking about, when you say, I want to Google, YouTube, Facebook, any of these ones where you're going really big, one of the things you have to think about is I need to approach how I'm dealing with data differently. It's not just one monolithic database. It's the idea of me making databases, data stores that are meant to do what they're intended for very well. So basically almost one-to-one to the query. So I'm saying, hey, I need to get information about available parking spaces. Well, here's an entire database, an entire data store that's been designed to efficiently do that query. Now, if you went to me a couple of years ago and you said, hey, Brian, you're going to be taking this data that comes in, you're going to be sticking it in, well, maybe 15 different databases just so that you can make querying easier. And you're going to just be writing, and each one of those is going to be custom. I refer to it as almost a data mitosis. The data kind of like cells, right? It gets split up and it exists in multiple places. If you told me I was going to do this, I'd say you're crazy, right? Everyone knows you got the one monolithic, super expensive database and everything goes in there and you just hope it can keep up. But now, with Google and their serverless offerings, their data store, their Bigtable, you can replicate the data incredibly efficiently. You can query it exactly how you need it. But the really cool thing is, it's also very cost effective. Mm-hmm. That's the thing that people usually pull their hair out when they hear about databases. They're like, oh, it's expensive, don't use more databases. But Google's serverless offerings for Bigtable and data store and those things and Spanner and things really let you do what you should do with your data.
So you're using a variety of each of these databases and you're using them as fit for purpose?
Yeah, exactly. It's not just, we only use one. We use data store when data store is right. We use Bigtable when Bigtable is right. We use Spanner when Spanner is right. That's the beauty of it.
Have you got a couple of insights for the audience about maybe when to use data store versus Bigtable?
Yeah. So data store is just, it's basically an object store. You can just take anything and throw it in there. And it's fantastic. We built the whole thing on data store, original platform. And it works fantastic. We went to Bigtable later because it helps with massive data sets. We're talking billions of the B rows, millions of columns. We're talking about massive data sets and being able to do those. So pick your database that's perfect for what you need to do with it. And
then you mentioned Spanner.
And Spanner's amazing, right? Spanner's that, you get this atomic operations across the globe. It kind of breaks your brain to think about it. And if you're very much built into the old ways, and I don't want to say old, but I'm saying the tried and true ways of doing data management within a massive single database that's atomic and everything, got good ACID and those kinds of things. Spanner's the way to go, because Spanner lets you have all that stuff. It basically lets you have your cake and eat it too. I mean, if you haven't read up in Spanner, go read it. It blows the CAP theorem out of the water, which
But thankfully Eric Brewer works for us now, and Eric Brewer wrote the CAP theorem, so we're good with that.
That's good.
Okay, so you talked a little bit about this with BigQuery, but maybe we dive a little bit more into those insights that you're deriving from that data.
Yeah, and again, the insights come out of the fact that we have all this data. We have really good tools. Like I said, BigQuery lets us do it. And then you have some really cool ways of representing it and getting out to people. So using Data Studio and whatnot. So you are able to not only get the data, but you have a really cool set of tools that let you make these reports that you can send out and share to people. So that's kind of also the addition that's in it. Now, from our standpoint, it's all about trying to reinvent the parking experience. So smart parking is not only trying to make cities smarter, we're also trying to make parking a lot more exciting. That means driving new kinds of guidance. That means driving new kinds of ways of cities and organizations being able to look at what they have and be able to get meaning from it. So again, that's driving not only analytics, that's a report that goes up to management, they're like, we need more money. It's also about the person who's sitting there on the street that says, oh, well, actually, which one of these bays should I go look at? If I'm a parking warden, I need to know that as quickly as I possibly can so I can get out of the rain and get the tickets out, or if I'm a person that's trying to find a parking space at the concert because I'm going down there. Those kinds of insights are things that we couldn't do before, at least not as efficiently as we would have liked, until we got into the Google's tools. Right now, it's a playground, and we keep finding insights we didn't even know because our people are literally just sitting there playing with our data, our terabytes and terabytes of data, and they're like, oh look, I found a really cool way of looking at data, and we're like, oh, I never thought of that. That's beautiful. Hey, we're gonna tell clients we've been working on this for a long time. This is great. So that's pretty exciting.
Well, it's very exciting. Yeah. And like you say, being able to open it up so that anyone can use these tools as well and not necessarily have to know how to write SQL queries. Yeah. If they're using Data Studio, for example, they can just drag and drop and get some great reports and visualizations from that. Now, you've mentioned Cloud Functions a couple of times, both over lunch with me and then both in the session today. So I know you do like yourself some Cloud Functions.
Yeah.
So tell me why they're so awesome.
So Cloud Functions may be familiar for people who are used to the AWS's Lambdas function. So it's the idea of these small little functions in serverless computing that basically do one thing and do it really, really well. So for example, I may have a device in the field and it may send me a message that says battery level is low. I can have a Cloud Function that reacts to that message coming in, specifically to the pub sub for health messages or whatnot, and immediately say, oh, battery level's low. I'm going to send off, put a thing in a table that for maintenance, or I can send a message over and we can just start that process. So Cloud Functions is this amazing new way of building your web architecture. It's the serverless way of approaching it. It's the idea that it's basically microservices done right. It's the idea that I'm able to take anything that's coming in and be able to choose how I want to react to it. And the beautiful thing about them is A, they scale incredibly. B, they are really, really cost effective. Like serverless is the way to go. I mean, you're talking about an amazing performance to cost ratio. And the other thing that's really exciting about Cloud Functions is it feels like magic. It feels powerful. You're like, I'm able to branch. So one of the things that people always worry about when they're doing development, I'm sure the audience has had this here, is like, how do I introduce a new feature without breaking the old stuff? Well, the cool thing is if you're using PubSub and you're just taking messages off there and you're triggering Cloud Functions, you can just say, well, the old stuff can work. I'm not going to touch it. I'm just going to branch off here. I'm going to take the exact same messages that are coming in, but I'm going to do something different, right? And so that non-destructive approach to all of your software because of Cloud Functions and serverless is really cool. Now, you wouldn't do it if it costs a lot of money, right? You're not going to duplicate your you might use some cool container management system. You're like, we're trying to save money here, but everyone's got their limits. But with Cloud Functions, you're like, nah, we do millions of invocations of Cloud Functions every day, and we're talking pennies on the dollar, and it is absolutely amazing. So we are fearless when it comes to expanding our platform. A new young guy comes in, go crazy, man. Just branch off any pub sub and do whatever you want, and we'll show it to the executives. It's a pretty exciting way of doing software development.
I'm getting that vibe from you.
Yeah, I know, I love it.
Now, you've talked a little bit about microservices, and traditionally when I talk to customers, it's about Docker and Kubernetes and those sorts of conversations where people seem to associate with microservices. Mm-hmm. But you're talking about event-driven architecture. So why did you go down this approach instead of, say, the Kubernetes and Docker approach?
Yeah,
containerization.
And that's one of those things where we had a lot of conversations. But like I said, when we were doing the initial research of this, we were looking at the trends of how people were doing and tackling these problems at scale. And that's the thing. You want to be able to scale as quickly as possible to the capacity you need. And serverless and Cloud Functions allow you to do that. And that's one of the things that allows you to do microservices right is the fact that you can scale each part however it needs to, whenever it needs to whatever it needs to. And it's beautiful. And then we do it the event-driven architecture because event-driven architecture is great. If you haven't checked it out, you should. It's the concept that everything in your architecture is an event. You don't have chunks of data, you have events that are going through, and then you do aggregates on those events to get views into what's going on and how things are changing. Beautiful architecture. We've always wanted to make an event-driven architecture, but the problem was doing it right meant having a lot of database per microservice, having a lot of microservices and being able to scale all them. Before I was doing Cloud Functions and using all the serverless data store systems that Google had, it was a pipe dream. But now I can do it cost efficiently and I can do it properly. It's like the nirvana of software development. I love it. I'm just absolutely. That's why I'm here. I want everyone to know Cloud Functions are amazing. If you haven't tried them, give it a try.
Now, Cloud Functions haven't gone GA yet, so again, they're in beta, and they're currently up in the US. but we're down here in little old New Zealand.
Yeah.
So have you had any challenges accessing cloud functions in the US?
Yeah, and we haven't had any challenges. So that's one of the things that people will talk about. Google is constantly coming out with all sorts of new cool things, and they put them through betas before they go generally available. And you can generally get access to them and use them, but they're usually based out of their US sites and everything. So you're like, well, what's the latency like? Well, it's one of the things that people need to realize when you're talking about GCP versus something like AWS or Azure. There's a key but very subtle and important difference. Google owns their network. So Google owns the fiber that builds their network. And what you need to do is just get to the edge of that network. Once you get to that edge, you are going as fast as it can possibly do for sending around data. So yeah, cloud functions are in the States. Our data stores are co-located in the same sector, the same region and everything. But we don't have any problem with latency. I will literally sit down at my keyboard and I will say, all right, I'm gonna do a query against big table, and I will hit enter and it will appear boop, instantly. Because all I have to do is do that first hop over to the edge, and then once I'm in there, I'm in Google's network and I'm going really, really fast. Like I said, it doesn't sound like it's that big of a deal, but trust me, it is the game changer. It is the thing that lets you say, I'm going to deal with data at scale because it's in Google's network. It's all secured, encrypted, and at rest and everything. So it's all my data. It's all there. It might be on the network, but it's mine, and I can do, and I can move, and I can use it however I want. So it wouldn't work without that, to be honest.
So we've talked about some of the cool ways that you're using Google. So what I'm thinking is, I drive into a car park, and then I look up and I can see that this floor has 50 car parks available. I go and find one. I find a green indicator. It shows me I can park in that bay. So I'm driving over one of your devices. Help me walk through the flow from when I hit that device. What happens? Where does that data go to? And then just walk us through that high-level architecture of what you've talked about.
Yeah, and that's the thing. So, like I said, smart parking's always wanted to be cutting edge with their technology to make sure that we deliver the latest solutions to our clients and to the citizens of the cities. So this one is, you have the sensor that's detecting it. We use a combination of infrared and magnetics to make sure we get the right thing. Radio frequencies are sending it to a gateway. The gateway then is responsible, we call them smart spots, and these gateways are designed to be able to communicate not with just our devices, but all the devices of a city. So that's actually part of the secret sauce of the whole architecture. Data coming from here, but let's say we have something else. We have a camera that's also giving us data about the parking thing, or we have some sort of arm, or we have a trash can, a smart trash can that's saying it needs to be unloaded. All that data flows into the smart spot, goes into our one central system, our gateway for the city, so to speak. It then goes into IoT Core. IoT Core gets you, all right, we're good to go with this. And then it goes into pub subs, and the pub subs then trigger off based on which messages are going where. So I got messages from trash cans. I got cloud functions that deal with that. I got messages coming in from parking. I've detected that there's reading changes. I interpret those reading changes and say, oh, a vehicle's arrived. And then I can then go store it into like a big table or something, and then that event will then be broadcast. So we got the event of device readings coming in, has been interpreted to an event of a vehicle arrival. Then anything that cares about vehicles coming and going can react to that event.
Wow.
Yeah, it's a lot of fun.
And I thought I was just driving into a car park.
Yeah.
And it changed to red.
Yep.
There's a lot going on. Yeah, a lot going on behind the scenes. So we've talked about a lot of cool GCP things, but is there any other GCP magic that you want to call out?
Yeah, I mean, one of the things that I've always amazed me is when we started doing this, it's how close you are to the developers at Google, right? That Google uses their platform. They use their cloud. All the providers use their own cloud. But Google is using it, right? They're not just saying, I'm just going to build the thing that's good for YouTube or good for Gmail. They're also very curious in how everyone's using it for all their different kinds of data. So the distance between me and the developers that are actually working on these things in the cloud feels ridiculously small. Perfect example. When we were doing cloud functions, I was on the messaging group for cloud functions, and I said, oh, it'd be really cool if we could have it so that when we're installing a new cloud function, the other one stays live until the other one's been verified, and we flip it over. Type that in there and say, that'd be really cool, enter. Someone from the team's like, that's a great idea, we'll get it in there. Replied to my message directly, and then I think it was literally a week and a half later, it was available. So, I mean, just be able to just kind of say, I'm gonna do this idea, and to feel like Google is responding to you and reacting to you because they want to build a product that's not just for Google, although it's got to work at Google scales. They also want to build something that they know is helping that primary vision, the idea of making data universal, making it available, not just like changing the world, so to speak.
You got a good handle on our mission statement there.
I know.
Almost got it. Love it. So let's talk about implementing cloud platform. Has that changed the way that smart parking works?
Yeah, and like I've always said, smart parking is always wanting to make sure that we're driving cutting edge technology, the latest and greatest, not only for our benefits, but for all of our customers and everything. And Google has definitely changed that. I mean, one of the things about it is that, and as I've mentioned through, it's a lot of fun, right? I can build things. I can build a platform and a prototype in a day, and then I can try it out. I can make it live, and I can literally make it live and not worry, because I know that I'm not going to break the existing stuff because the way we've built our architecture. But also, since we're using so much serverless stuff, Google kind of is our ops team. I don't have to be the DevOps guy anymore. I'm using serverless. I know it's going to scale. I know it's going to work exactly how I need it. I don't have to handle the call at 2 a.m. because Google's got it, right? And that's a good feeling. And it makes you more fearless, right? And it makes you feel just like you're in a playground and you like, I'm going to try things. I'm going to do things. I'm going to shift data because it's so cost efficient. It's so fast to try these things. It really changes the way you approach software development. You're no longer thinking about, okay, well, we got to do the right thing for the money. We got to do the right thing so that it matches the old way of doing it. And I want to try these new things, but this is the way it is. I know Google really lets us go have fun, try things, expand things, and basically be those kind of fearless developers that we've always wished we could be.
Have you found you've been able to be more flexible, like just going into the cloud console from wherever you happen to be at the time and tweaking things if you're not in the office?
Definitely, right? I mean, like you can go in there and you can just, not only can you go in and just try and tweak things, but you also have the ability to say, well, I'm just going to go try out something new. You can go to the console and immediately say, well, I want to just start using data over in BigQuery and Data Studio and shifting it around. The synergy of all the things that are connected there. And that's one of the beauties about Cloud Functions. Yes, I'm talking about Cloud Functions again. For the Cloud Function team out there, I'm giving them a heart. It's really liberating because also it connects to everything in there very well. So I don't live a lot in the console. I live a lot in my code, and I can just try things out. I can literally be, all right, I'm just going to throw this over to Bigtable. I'm going to try this row key. I'm going to do all these other things. And I can do that because it's cost effective. The security's there, and it's just a heck of a lot of fun. So it's like a playground, really.
And do you have to do all of that from your desk, or are you able to get out about?
Oh yeah, no, you can do it from anywhere, right? Because once you have the Google account, you get access to everything, and the command line interface. So for all the Linux people out there, the CLI for Google Cloud is beautiful. It's amazing. You can log into your project. You can do whatever you want. You can log into another project. I don't know who works on their CLI, but there's probably a lot of people, but they need gold stars. They need gold stars. It's great stuff. So if you like using command line interface for interacting with things, and you don't want to be one of those people who writes out the 6,000 character command line thing, right? It's not like that. It's an actual well thought out command line interface that lets you do things like spin up your Cloud Functions and do those things. If you want to do those, you got to give it a try. Yeah. So then you can do that anywhere. Just anywhere. You give me a terminal anywhere, I can log into my account and I can start doing stuff related to my project.
I'd say maybe from the beach, but I'm not entirely sure it's the right day for that. So we do have a little bit of time, so this might not be my last question, but just a reminder to you guys out there in the audience as well, if you have any specific questions for Brian, make sure you're putting them in the Q&A in your console that you have, and then we've got some guys online that are answering them, but also Brian will curate a few of them, and Brian will answer them live for you in a few minutes. But what does the future of GCP look like at smart parking? How's its use going to evolve?
Yeah, and one of the things that I haven't probably touched on as much as I could is some of the other additional tools that Google makes available, and a lot of that's related to machine learning. So machine learning's got a lot of buzz about it, and Google is kind of at the forefront of machine learning. And one of the things that they do is make it so it's really easy to get into the machine learning thing. So us at Smart Parking, like I said, we're always looking for the cutting edge. We would love to be able to say, hey, we're not only going to guide you to a good parking spot, but we're going to figure out what's probably the best one for you based on information of where you're going, how you like to park. Me, I hate parallel parking, right?
You're American.
Yeah, exactly, right. I want to just go straight into a parking spot. And that kind of data, that kind of understanding and predictive analytics of what's available and how to move people around, all those guidance things and everything, that's the future, right? It's bringing in machine learning. It's bringing in the Vision API that Google has, so I can recognize things like makes and models of cars or license plates for people who just want to park and just walk off, and I've already got my account set up. We're really trying to reinvent the parking experience. I've said that before, but it's what it is. You just, everyone parks, right? You got at least 2 parking events a day, going to work and then coming home, right? Everyone's got that, let alone, hey, you got to go to the market, you got to go pick up the kids from the school, you got to go see the movie, you want to do all these things. There are a lot of parking experiences that we go through, and we want to be able to say, hey, how can we make those things exciting and convenient for everyone? And to be able to do that is not just about having a really good idea. It's also being able to work through it, prototype it, try it, and get it in front of customers as soon as possible. And GCP lets us do that. It really allows us to come up with a great quirky idea, or maybe stroke of brilliance, as I like to call them. But you do one of those things, you work it out, you try it, and you're able to kind of see it and get it to the market faster than the competition, which is key, because everyone's trying. Everyone's trying to do something good. So GCP really allows us to do those things. Like I said, machine learning, the vision API, you get the language ones that allow us to do the voice to text and analyzing those things, which is really important too, because everyone wants to move to the realm where people are just kind of freely communicating with their devices. Hey, personal assistant, whatever, I need a parking spot next to the bank. And it'll know what your bank is, it'll know where you need to go, it'll know all these things. And that's the other thing too, is we're looking into a future where it's not just your data, it's the data of everything. It's the data that we want to make available for any city. Because if I'm a coffee shop and I want to be able to say, well, how many people are parked in my area? Can I say there's no one parked here and send out a coupon? How would I do that? Well, or if I was someone who was running a stadium and I'm like, well, what's the average parking light for here? I'm like, oh man, it's not very good. Maybe I should get some more buses running to and from it. Or more importantly, the real vision and what we really want to strive to do is be able to make the city smart enough to be able to say, hey, it's the end of the workday. Everyone wants to leave downtown. Can we detect people leaving and parking events and be able to translate that into changes to traffic lights and things like that? So it's not just about us bottling up and having just our little set of parking data. It's about collecting city data, making meaning from city data, but also making it available to a wider audience. And every time I say data, available, I'm talking about scaling. And if you drown in the data lake, there's no value to it, right? So you got to find a way to really find a way to easily access it and use it and respond to it. And that's what we're doing at Smart Parking. And it's one of the things that GCP has enabled us to do. And we like I said, I think people can see how much I've enjoyed working in that space.
I think it's starting to come across.
Yeah.
So you're predominantly in English-speaking markets at the moment, right? New Zealand, Australia, UK.
Yep.
So if you were to go into the, say, non-English-speaking markets and perhaps translation APIs, those sorts of things could start to be great.
Exactly. And that's just an example of all the cool things that you get it. Google keeps coming up with cool, exciting things, and my data is right next to it. It means that I've got my data here, and Google came up with the next cool, I don't know, it converts your data into a cat. I don't know what it does.
We are good with cats.
Yeah, it's something like that. And my data is there, and I'm just literally a few clicks, a few lines of code away from taking all my data and doing something. So it's a good place to be with your data. That's the thing that people don't realize. You can have your data anywhere. It can be any cloud, but what's in that cloud? Google's services is that lightning that goes through there, right? And we want to be there with that lightning, so to speak.
Fantastic. Well, thank you so much, Brian. I hope everyone else is feeling how excited and passionate Brian is and some of the great stuff that Smart Parking has been able to do with Google Cloud. So thank you to the audience for joining as well. Really appreciate your time, and I hope you've learned some valuable lessons from Brian and perhaps how you can implement some of those in your own business. Now, just a couple of reminders before we jump into your live questions. So you've got a couple of things that you can do to start getting involved. Get certified. You can see the links on the page here. We've got a couple of different, or actually a raft of different Google certifications now, so feel free to jump in, start doing some training, start doing some learning, go sit the exam and become certified and really be able to enhance your career and enhance what you're doing with Google Cloud Platform as well. Tons of hands-on labs online if you'd like to jump in and really get hands-on with some of the things. Play with cloud functions. Brian will love you if you do that. Go to Coursera. We've got some great online training, both by authorized trainers and also by authorized Googlers as well, who are able to train you. come and talk to us. The links are here. Come and talk to your local Google account teams about what your business is doing. We'd love to hear from you. And don't forget, there's also a free trial you can take advantage of as well to dip your toe in the water. And up next is Marco, who's going to be talking about cloud IoT in a lot more depth. So you can hear a lot more of the technical details beyond the services that Brian's been taking advantage, as well as showing you some really cool demos. Now, we're going to be back very, very shortly to answer a couple of your questions live on air with Brian. So we'll see you in a second. Thanks, guys. All right, we're back. Thanks for staying with us, guys. Okay, so we've got six questions that have been curated from all the questions that have been streaming in throughout the session. So first things first, somebody, we'll call him Bob. Bob has said, hey, this sounds pretty cool. How would you recommend somebody else getting started?
Yeah, so you just covered that. There's some great training materials, but I mean, I think the thing the way I did it was you can just get in there. I like that they give great descriptions. Their documentation's actually really good. So for people who are familiar with other clouds, you might realize that, hey, you can actually have good documentation for cloud services. But the example code's great. You can literally download it and then you can try it out. You can get the free trial and you can do all sorts of things. And they've done a really good job of putting all those little examples together. So go check out some projects on GitHub and just give it a go. Get the CLI and you're golden.
Now, people have obviously been listening, which is great because we talked a lot about scale.
Yep.
So just talk a little bit that come with
scaling for a developer means that I just wanted to function the way I envisioned. For the accountants, I want it to be efficient and not expensive. And for your ops people, I don't want it to fail over. I don't want to have to do anything manually. So the challenges of scaling are real, but cloud functions and all these serverless things, and serverless is not just a buzzword. I used to think it's a buzzword, but we've embraced it. And I don't want to develop software outside of serverless ever again. It's so liberating. And when you get really well-designed serverless services, so data store, big table, cloud functions, BigQuery, when you get those, data flow, there's one I forgot to mention.
Yes.
Data flow is a good one too.
Yeah. For the audience, give us 2 seconds. What's data flow? How does it help you?
Allows you to take your data, be it coming from an external source or something internal, and perform a kind of transformation, map reduction. So Hadoop, for people out there who love it, scaling. You don't have to worry about setting up the clusters or anything. All that stuff just on demand. So it's a really powerful tool. But again, it scales. It scales to what you need. It scales beyond what you're going to use because it's built for Google's scale, internet scale. It works for city scale. But it also is cost efficient and they're managing the servers. Things don't fall over because Google's got all that stuff in place. So they're your ops team. And so that makes everyone happy. It scales the way you want as a developer. It's cheap and cost efficient when you're the penny pinchers. And if you're the ops people, you don't have to go do anything manual. So
great
good stuff.
Now, someone's obviously read your case study. So if you guys haven't, Smart Parking have done a case study for us, and you can read through in a bit of detail about what we've been talking about today. So someone's asking that you mentioned in that case study that you shifted from thinking about yourself as a devices company to a data intelligence company. How did you make that mindset change?
Yeah, changing mindset in any company, especially one that's established and has established itself as being successful, is really hard to do because there are a lot of people who know what you're doing worked. Why change it? Why do you now saying we're a data company? Why are you changing these things? So it's not an easy process, but I think one of the things that we did is it's really been from the very beginning, it's been about communicating to people and letting them know what we want to do, but also showing it. So the joy of being able to prototype something quickly and being able to do it without saying, well, we're going to take all the data from our old archive data and we're going to move it over here and we're going to try all this stuff and be like, ooh, that's going to be expensive putting in your database. No, it's changing the mindset. The proof's in the pudding, so they speak, right? You you love data, you embrace data, and you find the tools that let you play around with it really quickly, and that'll change your mindset, because then you begin to get things where some random person down at the other end of the office that I've never talked to comes down to me and says, "Hey Brian, I just found out a great way to look at this report so that we can determine what's the peak time that people are coming and going for different spots based on their locations." You're like, "That's amazing. Who are you? Thank you for bringing that to me." And it's just because they began to think about it as a data. What can I get out of my data? So letting people, the data democracy is a great way to change the mindset. Get everyone involved.
So people can touch it and feel it, they can start to believe in it, get excited about it themselves, and I guess feel a sense of ownership themselves and take on and drive it themselves.
Exactly.
Oh, brilliant. Okay, how does parallel computing play its role at smart parking?
Yeah, so parallel computing is one of those things where there's a lot of ways to define it. It's a loaded word. Asynchronicity, parallel computing, all that stuff. So how are we doing this and scaling out? So for us fundamentally, a lot of what we get is parallel computing. This ever-expanding kind of thing happens at that cloud function level, where we're saying, hey, every single thing is an expanding service that's running in parallel, and Cloud Functions allows us to do that. And when you're talking about scale, that's the things that are interesting. Again, data flow is another example of where you're saying, I want to be able to take a massive chunk of data. I mean, in BigQuery works the same way. You're talking a massive chunk of data. I want to break it apart and put it out into a number of systems that do their piece, and then I'm going to reduce it together, reduce it together, reduce it together. The whole fundamental of maximizing parallel computing is at the very crux of what Google does. And it's one of the reasons you come there and you're like, yeah, all this stuff's parallel, right? Because I issue a job to Dataflow, I issue a query to BigQuery. It's going to massive numbers of machines that automatically they're doing tasks in parallel. So I can take a terabyte of data, run a really poorly written SQL statement, and get the results in 2 to 3 seconds. And you're like, yeah, that's amazing. The only way you can do that is through the parallel computing that becomes baked into the very fundamental soul of GCP.
So speaking of the fundamental soul of GCP, not answering the question for you, but how has smart parking deployed its services to achieve fault tolerance and prevent data loss, which is key?
Yeah, and this is very key. And so there's a couple of things for fault tolerance and data loss. A lot of it has to do with how you're monitoring your stuff. So it's just like solving the halting problem, right? You're not going to be able to catch everything. So you look at best effort. And the way we like to develop software is, you have to be aware of what's going on in the system, right? And Google gives you good visibility into it. And we've built a lot of tools that allow us to monitor it. But to prevent data loss and everything is, we want to take data that comes in and we want to not stop it. We want to bring it in and we want to get it and we want to write it as quickly as we possibly can. So Cloud Functions and PubSub let us do that. PubSub is an amazing service that's designed to get you that message, and it's going to get it to you. Now, it may come out of order. You may get the same message twice, but you're going to get the message. Yeah. So saying that we're going to use PubSub is a great way to begin to fight that battle of any sort of data loss. You take it, then you write it down, and you've got a copy of it. Use deterministic programming methods and things like that to say, hey, what we're going to do is we're going to take data, we're going to react to it the same way every time. So data loss and fault tolerance comes at that kind of fundamental level of how you're developing your software. But fortunately, when you begin to think of microservices and you begin to think of Cloud Functions, the problem becomes much simpler because you're shrinking down what you're doing with data at any given point to a tiny 4 or 5 lines of code. You know what it's doing, and it's taking a copy of data, it's doing something, it's putting on the next thing. So again, the fault tolerance and the prevention of data loss is also important to Google. So the system they're using to send messages back and forth and make sure they don't lose data is also the stuff we're taking advantage of.
Now I'm going to sneak my own question in there as well, just because it's something you said piqued my interest. Yeah. This is how it works. We're live. We can do what we want. So quick question. So you've talked about data may not come in at the right time. It may come in later. So do you have to deal with late data or data windowing or anything like that?
Yeah. Everyone does. So that's the thing. Is as much as you want to resist it, streaming data is data that arrives slow, data that relies duplicate data, and of course there will be missing data. And there's a lot of different techniques of how you want to deal with this. Like, for example, that device that's in the ground, it may lose communication. There could be a solar flare that knocks out radio frequencies. You don't know. So you have to be able to do that. And so all of these things are at play where you will potentially lose messages, lose signals, and do with those things. So we've developed a couple of ways of doing it. Like I said, this microservices, this take data, save it, and then move on. But there's also a lot of windowing. So data flow offers an incredible set of windowing for streaming data. If you've never looked at windowing, they've got some great articles on it. So read through some of those, and it'll give you an idea of what you have to deal with when you're talking about large batches of streaming data. And so, yeah, windowing, combination of other techniques. But all in all, if you just have the ability to react to data, and you have the ability to just take it on, and I mean, lots of Google services, BigQuery does deduplication too when you're streaming into it. Taking advantage of those, you can get around those things that seem like really hard problems pretty easily.
Great. Thank you for indulging me with the question. So last question we have from the audience. So does IoT Core on GCP provide the data visualization in order for you to analyze your data, or?
Yeah. So that's kind of a loaded question because it has IoT Core on GCP. So IoT Core itself is designed for you to manage your fleet of devices. And as we've been working with them through the different beta release of this stuff and the general availability and things like that, they just add more and more visualizations to it. But the key point is that IoT Core is the gateway to get data into the larger architecture. Once it gets into the larger architecture, you can put it in Bigtable, you can put it in Data Store, or you can stream it directly to BigQuery. No matter where you put it, you can put it in Google Cloud Storage. No matter where you put it, you can hook BigQuery up to it, and then in theory, you can also hook up Data Studio to it and begin to get a visualization almost immediately. And so it's that kind of connectivity between incoming data and being able to visualize it really, really easily. That's like I said, a few questions ago, how did you switch the mindset? Well, you got to be able to view it. You have to make data something that people aren't just, it's in a closet, it's here, it's things people are interacting with and visualizing, and Google's tools make it so that we can do that.
Fantastic. Well, thank you again for your time. That is all the time that we have. I wish we had more because I sense we could keep going for a while. So thank you to everybody who's been tuned in as well. Now don't forget, stick around, come back a little bit later on when Marku's online, and he will be talking, as we said, in a little bit more depth about IoT Core. So for the person that asked that question, come and watch that session and see some of the great demos he's going to do. Thank you again for your time today. Thank you again, Brian.
Thank you, and I'd like to say thanks to the crew that was helping filming this too. They did a great job, so shout out to you guys. Appreciate all your hard work.
Thanks everybody. See you next time.